Hello, this is Talal Thibeti. I will talk about low-level interface assignment. In this presentation, I will talk about I2C and SPI and memory mapped input-output and physical interface. Starting with I2C protocol is a centralized serial communication protocol, work with time clock, and has two ways in communication. SCK is the transfer time pulse from master device to the slave, and SDA is the data transfer when writing from master to slave and when reading from slave to master. That means is a two-way to transfer. You can contact a large number of devices on these two wires, up to 40 devices or more. The question is how how the master device know which device transfer to. That's done by addresses. So each device has unique address. It's on it. When the controller send to the address, open the device responsible for the address and being to send to receive according to the last bit of the address where it's specified. This protocol it's half duplex type. There is either being sender or receiver. The advantage of this protocol, you can communicate with more than one slave using only two lines, and it's low construction cost and easy to apply. Can be disconnected and connected to any device for carrier without any impact of the system or need to change. The disadvantage of this protocol: short contact destination, maximum of 4 meter, low speed up to 400 kilohertz. The SPI, it's a full duplex protocol which send and receive at the same time. In this protocol, it does not have to send an address, but there is a special carrier selected chip that activate the terminal to be connected with when the logic 0 does the terminal and when logic 1 cancel terminal activate. It's the most used protocol in the controllers. The transmission of the large data can be linked from 8 to 12 device. So by this protocol and the single transmission line, the internal structure of SPI, there is a master device that communicate with one or several slave. The SPI transport from parallel to parallel with 8-bit parallel, and it's based on 4 line for communication with external unit. The MOSI, the master out slave, this plot is output when the device is master, and this plot is entered when the device is slave. The MISO, it's master and slave out is the plot entered when the device is master, and this plot is output when the device is slave. The memory mapped input and output, its way to exchange data and structure between the CPU and outer the device attached to it. The memory mapped input output is one where the process and the output or input device share the same memory location. For example, the processor and input output device are mapped using the memory addresses. The physical interface of a microbit has the USB controller and 25 LED light and 2 button. This is the front face and the edge control from accessories. So there is an accelerometer which we use in this project, and the compass, and this is the processor, and this is the radio or Bluetooth antenna, and there is a rest button in the back, and this is if you want to use the battery socket. So I did the code. I will use the BLE scanner to connect to the microbit. I name it as Dalal. So connect to Dalal here and show me the three surfaces, the LED and the magnetometer and accelerometer. The magnetometer is 12 and the accelerometer is 16. The magnetometer is affected by movement with 3 dimensions, X and Y and Z, and the magnetometer is affected by a magnet, and phone has magnet, so I will use it for this, and see by changing the direction of my phone for the 3 dimension X and Y and Z is it changed. Thank you.